Hey everybody, Justin down in my electronics workshop, messing around a little bit with some stuff that I've had kind of kicking around for a little while. This is a piece of equipment that is kind of one of those DIY component testers, and I never really thought much of these because I never bought one. But I actually do find that it is a pretty useful thing when you're getting into the electronics hobby. It's a fun project to build because this is one of those things that you buy from either eBay, Amazon, and you have to solder it together. You have to build it. It is ran by a PIC, programmable IC, microcontroller type of device. If I remember right, it's some type of an Intel all-in-one solution with a little bit of a display and just some fun things. But when I got this, I actually had gotten it in a box full of just stuff that was going to end up in a garbage from work years ago. And anyway, it wasn't working. It was pretty poorly soldered together by the previous person who put it together. So I went through and I did some touch up on it. It's still pretty poorly soldered, but it works. So I didn't feel like getting into it too deep because I wanted to make sure, first of all, could I just get the thing to function? It didn't come with a case, so I figured, well, I'll just have a look around, see if anybody else has come up with a solution for that, and sure enough, somebody did. It's actually a very nice design of a case. I'm going to see if I can open this up. It's even the knob is 3D printed. It's just a kind of a nice little design. I wish it did have a removable battery compartment separate from having to remove the bottom cover, because that would make things a little bit easier to manage, but beggars can't be choosers, and I'm fine with just struggling a little bit to replace the battery. What was really wrong with this when you can see some of the soldering I did touch up. Most of them are fairly clean now, but there are still some blobby ones. But most of the reason on what was wrong with this was, and it's a very weird thing. So at some point the LED must have been overvolted or put in wrong, or just something was wrong with it. And I never suspected that a light would stop this from working. And there's some type of a voltage sensing, kind of a current sensing thing about this, that the LED is actually a very necessary component to make this work. So after doing a little bit of sleuthing and probing around, and I'm like, well, that's weird. This LED is connected further in the circuit other than just being illumination. And that was the problem with it. That and some poor solder joints, but I fixed that. As you can see, it's just kind of a nice little compact design. The board fits in very, very securely. Oh, it's on because I accidentally hit it, but I'm not going to fully remove it just because it doesn't really need to be. But the idea is pretty straightforward. You have your battery, and wish there was just a little bit more of an extension on here and more like a battery compartment where you can just pop it in so it's separated from the board itself and you can just get to the battery. I might re-edit and make a new design for this, but it's still pretty darn cool the way that it is. So it's a fun project for those folks who are kind of wanting to get into a little bit of a DIY electronics. It's a fun project to work through because, well, it's pretty easy. The soldering work on it is maybe, I would say, mildly advanced, but not terribly, where if you had a nice pencil soldering iron, I wouldn't really use like the Radio Shack type plugins or the Wellers. They work okay, but the tips on them are usually a little bit too big for this type of stuff. I've had really good luck with this this type of soldering iron. It's a battery operated unit. It gets warm very quickly. It has a good temperature range. Not sponsored by Fantic, but I will say that I do sign off and I'm quite happy with this. It has a couple of different chisel tip and needle tip options. I currently have the swoop tip. I don't know exactly what you'd call it, but it works really well. I do tend to leave a little bit of solder on the tip itself after I cool it off, because that helps keep that tin coating on these in good shape. That was a nice helpful tip from Mr. Carlson's lab. He has some fantastic videos. They're a little drawn out and long sometimes. I find my ADHD, it's a little hard to listen to them for a long period of time, but then again, I'm pretty drony too, so. But anyway, Mr. Carlson's lab has fantastic videos, very in-depth, very informative. Everything that you should probably need to know or would want to know about vintage vacuum tube capacitors, which ones are worth keeping, which ones absolutely are replacement, don't question it type of stuff. Testing resistors, understanding circuit designs. That guy is he's great. In fact, I really would like to meet up with him sometime and shake his hand and let him know how appreciated he is in the electronics hobby. He kind of inspired me to do this too. So, but anyway, this is just a fun little project that you can put together as an amateur electronics technician. Even the advanced electronics technicians find them to be fairly useful. I'm going to go ahead and just throw a couple of random components at it and see what it says. So there's a calibration process that you can do on these to kind of set up some accuracy. But we'll just go ahead and pop this big old chunky bugger on here. I did solder the pins so that it is 111. So you have 3 pins on this side, on the left side, that are all set up to be pin 1. Same with the top row. 2 in the center, and then pin 3 going all the way down the line. So it just makes this type of stuff a little bit easier. It's a little tight for some of the bigger components, but it does work. I think if these didn't have a bunch of stuff left on them, they'd slip right in there. But this is kind of the upper extent. We'll just try this guy right here, a 2SC5297. Again, tight fit for this type of component, but we can make it work. I think for the TO like 290, 220 style components, this would be more preferred, but for video, you know what? I think that's what I'm gonna do. Sorry. You can do it. I just don't want to bend up those pins. I might designate a certain spot on here for the larger stuff. Modify that socket slightly. There is a potential of putting test leads on it, and I might do that in the future to make things a little easier. Yeah, here's my TO220s. Let's just grab, here's a bin of some brand new ones that I'd ordered. And these are questionable. I don't quite trust that they're legitimate. I ordered these for a car audio amplifier project, and they're supposed to be an IRF product, but something about the housing of this particular transistor does not quite inspire confidence. An FB42N20D. I'm pretty sure these are fake, but hopefully they are functional, because I have a car audio amp that needs them, and well, it is what it is. So go ahead and put the component in. We'll turn it on. Shows you your battery voltage, and it tests out as a NE MOSFET, giving you all the ratings here. You can see the the gain factor right there. Shows which direction the diode's facing, kind of gives you an illustration of its design for its drain, gate, and source. The VT for 4.2 volts on this one. Looks like internal capacitance of like, what, 2.3 nanofarad. So kind of handy. to have that information, and that can be sometimes useful for comparing transistors that you're trying to put in a circuit if you suspect they may be fake. I'd like to curve trace these and see how they actually do perform in real life. Here's a random bag of just pulls and parts. So let's just try out a few of these and see what they say. So this guy looks like it got pretty hot. A U1620, I'm not even sure what it is, but it is Motorola branded. It's like a date code of 1998, 22nd week, if I'm reading that correctly. So I'm not really sure what it is, but that's what this is good for. It looks like it is a dual diode rectifier. According to this, pins 1 and 2 and 3 and 4, diodes are going facing in. So that is a rectifier. Weird. Let's look at this. This is a brand new D669AC. Old new stock, I should say, not brand new. Let's test this guy out. Oh yeah. There's some functions on this particular unit that are a little goofy. And it has multiple functions and features. I think it could do frequency counting. BJT, NPN type, beta of 170, 183 millivolt. And there's the orientation. So that's a BJT. What else do we have? Here's a BTA16. Let's see what that is. I'll put this in my rectifier drawer. That is not right. Something is wrong with that one right there. 0 ohms and 43 ohms. It's showing it as 3 resistors. I'm going to suspect that that is probably not correct. But we'll try it again. Yeah, I think this one is no bueno. I'll have to look it up, but I do not think that that is good. And that is kind of why we have these things. Here's a D613. Let's pop that in this socket. There we go. BJT N-type, beta of 98 and 567 millivolts. So that's a working thing. Let's try this. This was a random pull from, I think, a older piece of equipment. Another BJT N-type, 61 on the beta, 615 millivolt. Do we have anything else random we can test? Here's another Motorola branded component. That is a 421-7. I'm assuming that's some type of dating. R930. So that's the fun thing. Sometimes you don't know what it is. So let's try to get it in here. Press and hold to reset the device. It's telling me to do a calibration. That's a BJT N-type, 80 on the beta, 547 millivolts on that. So again, B-type, BJT N-type. Here's a Fairchild branded 2SC2073-2. I think that's a MOSFET, right? No. BJT N-type 71, beta 635 millivolt. Let's see, another Motorola branded one. Only identifiable information on this, sorry, is 1237, and then it has some stuff on the bottom. What is it, a 020? Motorola is very secretive about their stuff. Can really throw a monkey wrench in your repairs if you're not up in the world of Motorola. So BJT PNP type, beta of 136 and a VF of 572. So neat, good to know. You can see kind of the usefulness of this. This one is hard to read, can't really tell what it is, but let's pop it in here and see what it says. Sometimes you can take some of that white ceramic style paste and you can wipe it on there and gently kind of wipe it off, and you can expose the actual numbers and letters to tell you a little bit more about the component if they're hard to read. Assuming it hasn't failed or burnt up, you can usually read them fairly well. And this one's saying it's a damaged part. It doesn't really know what to say about it, so I'm going to assume it is probably damaged, but we'll get that out of the way. Here's another BDX 63B. I think that's the part number. Let's go ahead and check that. These were just randoms I poured out of a bag. So BJT N-type beta 45, 1.08 volt. Here's an oldie but a goodie. Let's just see. 2SC 2278. BJT N-type. So yeah, you can see the usefulness of that. I'm gonna go ahead and just throw these back in the bag. Again, I didn't really, these are my poles and parts that always need to be tested or organized beforehand. This is just kind of my ADHD of put it in something and consider it organized for the time being while my parts bins are hanging out. Let's grab some diodes. I've got some diodes here. Some of them I know for a fact are standard diodes. Some of them are Schottky. Some of them are Zener diodes. Some of them I've already labeled. But let's just pull a random out of here and pop it in. So I'm just going to go and put it across any random pin assortment on here, assuming it's separated. And let's go ahead and test it and see what it says. Okay, it does show that it is a diode, and the band is associated in the right direction. The band is here, and it's showing it on the screen that it's there. Forward voltage of 747 millivolt. Internal capacitance is 0.33 nanofarad. So let's see here. IR is 4 Na. I'm not really sure what that is, but these are easily readable, and I do know for a fact that this is a Zener diode. So I'm not sure if these are going to identify Zener diodes specifically. I do have a pack of standard general purpose Jabadoos, I think, right here. Let's just pull one of those out of the package. This is what is this? Let's just go ahead and P6KE18A. Not really sure exactly what it is, but let's go ahead and pop it in the tester. Okay. I don't think that's a Zener. I think that's more of a general purpose diode. 688 millivolt forward, 1.3 nanofarad capacitance, and an IR of 4 nanoamp. Is that right? All right, let's grab what I do know is a diode that is more of the general purpose type. So I do have a few of those kicking around. These are just sort of I didn't have a place for them necessarily, but this is where they ended up. Oh no, I dropped one. Oh, here's a unique one. I think this is a germanium, not the flower, germanium. Germanium? That type of diode, glass type, very sensitive. Let's see what that one says, because that can potentially be unique. Part unknown. Bad connection, maybe? That's another glass type. It is identifying it as a diode. 893 millivolt forward, 0 capacitance, 4.7 UA, so microamp. So there you have it. Those are very commonly used in crystal radio, very sensitive, low voltage sensing type of things, like meters for SWR or SWR bridges. Sorry, just picking up a diode on the floor before it gets lost completely to time. So very useful little device here. Here's some standard diodes. I'll just pull a random one out of this bin. It's a 1N4002. Pretty standard affair. Again, we'll just pop this in. See what it says. Yep, band is facing that way. 669 millivolts forward, 11 picofarad capacitance, which sometimes on your circuit design, sometimes in your circuit design, you will find that that can play a factor. And a IR of 6 nanoamps. So I think that I'm reading that right. But again, it's just kind of a handy tool. So I think that's going to conclude today's video. Hope you guys found this fun, nerdy, enjoyable, and everything else in between. If you did, hit like, hit subscribe, ring the bell if you want to get the notifications when I'm rambling on. But in the meantime, stay nerdy, and we'll catch you in the next one.